All right, so first thing first, um, I've spent the last year writing about 50 papers to work on my administrative program, and I do that by talking to text using Google. So in this recording, most likely, I will punctuate my sentences once in a while as if I was dictating this um, to one of those papers, but hopefully I won't. But anyway, if I say period once in a while, just you can laugh all you want, but that's why. So even though I'm not here, we are going to do a lab today. It is called Yes, Ma'am, and it's just right there in the first page of your lab book. So if you would all take your lab books out now, that would be awesome. Okay, so you can see, just real quick, should be right here, and we'll cover this in a minute, but right there on page number 2 is Yes, Ma'am. So the first thing I want to make sure you are very clear with is the safety requirements for this lab. So in this lab, we'll be dealing with concentrated acids, so it is important that you have safety glasses and aprons on at all times. This is including cleanup, because once in a while, kids will turn the sink on too high, and that will that'll splash out of your micro well plates and splash acids everywhere. So make sure you have your aprons and your glasses on at all times. Then when you're done, just make sure to rinse your hands with water and dry them off. That'll get rid of any residue. And then make sure all of the waste, because you'll have to use your trays more than once, you first dump it into the garbage can and kind of tap the tray on the side. And then you can go rinse the micro well plate in the sink. And then in giant here in red, you're going to have 5 elements or 5 samples back there. Number 4 is very expensive and cannot be thrown in the garbage. So do not throw number 4 into the garbage. Tell your lab partner right now about number 4. All right, so do not throw it into the garbage. Use your tweezers to get it out and rinse it, and then put it back into the sample cup. And we can use that over and over. Now, excuse me, when you get number 4, well, let's go here. So when you do these chemical or physical tests, when you're describing the color, if there's any large chunks of things, you're going to describe what the larger piece looks like. So number 4 will have a big chunk. It'll be shiny, you'll see it. But when you do your chemical test, just take a little, very small piece of all of them to react with. So whenever you're describing what it looks like in this color column, that's what you would look at. That's the bigger pieces, if there are some, and then the smaller pieces are what you will do the chemical reactions with. So let's go ahead now and write in the hot water, cold water, and acid in these boxes. Okay, so this is very simple, and you're going to have the same pipette for both the hot and the cold. So it's just one water pipette, don't look for 2. And then the acid pipette will just say HCl. I'm writing with a mouse, so it's not going to be very pretty. HCl will be the acid that you're going to use, and that will be in the fume hood. And the hot water will be the one on the hot plate, and the cold water is just room temperature water. You can get it out of the tap or out of the beaker on the table. Anyway, so those are the chemical tests we're going to do, and it's a pretty simple lab. So what you'll do, so for instance, I already have sample number 1 in here. All right, they're all 3 the same sample. And what I'm going to do, I'll put 1 piece of each thing in here. And then to 1, I use the pipette to add cold water, and then hot water for this one, and then acid. And I'm just looking to see if a reaction happens. If a reaction happens, we're looking for like bubbles. Okay? If we see bubbles, we know a reaction happened. But if it doesn't bubble, it still may have reacted. It just might not be very vigorous. So if, and you'll see this in the instructions in the yellow folder if you pick those up, if when you added cold, hot, and acid, if let's say that these bubbled here, Okay, we'll just put some red dots. And we'll say this one bubbled a little, but this one didn't do anything. So these two, I wouldn't really need to do the next step. We already know they react. So if there's not bubbles, like would be here, then you use a pipette and you add phenolphthalein. Phenolphthalein's pipette just says pH on it. And if a reaction has happened, when you add pH, the solution would turn pink. I'm really wasting my time here, probably writing with this, but whatever. If you put pH in it and nothing happens, then in your notes just put NR, which stands for no reaction. Okay? You will do this for each one of 1, 2, 3, 4, and then you would have to rinse this out and do it again for sample number 5. Please remember, multiple reminders here, do not throw number 4 away. Get it out with your tweezers, rinse it off, and put it back in the cup. All right, so once you have this data collected, then you'll be ready to answer these questions. And so right here it says use a flow diagram to separate the 5 elements into 3 groups. And what I would like now is for Heather or the substitute to pause this, do the lab, and then come back and press play when you're done. All right, let's switch this up and hopefully it doesn't change too much. Okay, so now you have the data and it's time to create our flow diagram with this data. So what we're looking for, a flow diagram is a flow chart. And don't use this one, but remember, the flow chart is where you ask yes or no questions to separate things into groups. So in our homework a long time ago, we had a flow chart to separate cats, rats, and dogs. And so, like, does it bark? Yes. Dog? No. So we need to ask a second question for the no. Does it meow? Oops, whatever. Yes, that'd be a cat. And then this would be a rat. That was a simple flowchart with yes and no questions to learn how to do a flowchart. So now what we're going to do is a flowchart where we separate these 5 things into 3 different groups. So it's not very simple. The number of questions we ask is always 1 less than what we need. So we only have to ask 2 questions. And really, there's some that I like better, but you can ask any of these questions. Like, is it silver? Does it react with hot water? If that's a different order, I apologize. Does it react with acid? Whatever you need to do, you just ask that question. And so your flowchart should look something like this. Now, it depends on which side you put the yeses and no, but it should just look something like that. These 2 would be questions, and these would be the numbers, let's say like 3 and 4, 1 and 2 and 5. And I made that up. I doubt those are the right groups, but that's how you'll do this flowchart. So go ahead and pause and work on that flowchart if you would. Okay, hopefully you have that flowchart all set, and this might even be the next day. I'm not sure how long this was going to take, but here we go. Now let me tell you what these are. Number 1 was Mg, 2 was Ca, 3 is aluminum, 4 is Sb or antimony, and 5 is bismuth. Write those in now. And then we will answer the next questions. So it says number 2, which elements belong to family 2 of the periodic table? Well, from our lab, you can look. Family 2 is the second column over. So you've probably already answered this. They were Mg and Ca. That's ugly, but whatever. Rank these elements from the highest reactivity to the least reactivity. All right. This is a poorly written question, and I can only blame myself. If you answer it from number 2 and just do the 2 questions, you would have noticed that calcium was more reactive than magnesium. If you do the entire activity, meaning we take all 5 of them, they would be ordered like this. Your most reactive would have been calcium, then magnesium, then aluminum, then SB and BI don't really react, so it's not really rocket science, but what we learned from the activity yesterday is that since BI is lower, it will be more reactive. So that would be your answer to number 3 if you included all of them. Okay, rank the elements in order of reactivity as they progress from left to right across the periodic table. So pretty much this, oh, that was ugly. This can be the answer to both. It just depends on how you did it. I can't get that, but it also works for number 4. Okay, so based on what we've done now, the demonstrations and this lab, we now can write the reactivity for metals. We learned today that as we went towards the left, they became more reactive. We learned in the video and demonstrations that as we went down, they were more reactive. So down here at the bottom left, like FR, would be extremely reactive. Okay, hopefully that made sense. We'll fill a little bit of notes, more on this, but we'll just end this video here.